Welcome to 2.4, Curves and Circles. I'm not sure why it's called that because the first thing we're going to talk about is triangles. Okay, this lesson has a lot of definitions. I apologize for so much writing, but it was unavoidable. So a triangle is the union of segments that connect three non-collinear points. A triangle is designated by the symbol, there's a little triangle, followed by the three non-collinear points. Okay, so here order doesn't matter. You can call a triangle ABC, CAB, BCA, because they are all vertices. Okay, so here are three vertices of three different angles, and we're going to connect them with segments. So we're calling this triangle RST, but like I said, we could call it any combination of those three letters, and it would all be the exact same triangle. Okay, it's important to recognize opposite sides because those segments are called the sides of a triangle. That if I talk about opposite angle, the side opposite the angle SRT would be, okay, I said the wrong angle first, my apologies. If I said the opposite of RST, you would have to know that is segment RT. Opposite RTS is segment RS. And the first one I said, okay? So, hopefully we're all clear about that. The one thing I did want to talk about with the word triangle, your textbook on page 54 goes into detail about triangle is a Latin word where tri means three, and you've heard that before, and angulus means angle. Okay, but we also want to talk about the word trinity, and triangles have been used to explain the gospel and the Trinity with the Latin words trineus, which means threefold. Okay, in our Godhead is Father, Son, and Holy Spirit, and it talks about that in Matthew 28:19, that they are all equals. Okay, so just a little Bible study thrown in with your geometry. Let's talk about some differences of just regular angles and then the angles that are in a triangle or of a triangle. So angles of a plane, they are subsets of a plane. We talked about the half plane theorem and how this is the intersection of two half planes. It has an open interior, meaning that interior goes on infinitely in that direction. And it's also made up of two rays. The differences of angles of a triangle is that it is not a subset. Those angles are not subsets of a triangle. Okay, they are a part of the triangle. It's also a closed interior. It is finite. Okay, it's a specific area, which we talk about later on. And it's made up of segments. Okay, which segments are subsets of rays. So if you were to extend those rays still do go on infinitely in those three different directions, but we are subsetting those into segments. Okay, so one of the student errors is they get confused just by the word of when we say angles of a plane, angles of a triangle. Okay, it can mean different things, just like a book of a series is different than a book of gardens. Okay, a book of a series means it's just one book of many books. Okay, but a book of gardens is a subset of a garden. Okay, that book is going to display a lot of gardens. Okay, so similar but different. So hopefully that clears up how the angles of a triangle are different than the angles of a plane. And we'll finally get into what the title of the section is, Curves and Circles. A curve is a continuous set of points. A closed curve is a curve that begins and ends at the same point. I'm sure you can think of a curve that begins and ends at the same point just off the top of your head. A simple curve is a curve that does not intersect itself unless the starting and ending point coincide. Okay, so if I begin and end at the same point and that happens to be exactly the same spot, then it's considered a simple curve. A simple closed curve is a simple curve that is also closed. So let's look at some examples. First off, hopefully you thought of right away a circle, but the official definition of a circle is the set of all points that are a given distance from the given point on a given plane. So I want you to think for a second what that given distance is called, because I know you know this vocabulary word already from previous math classes. The center of a circle is the given point in the plane. So if I start from the center and I go a given distance in every direction, I will have a circle. So here's a center, and here's a circle that is this given distance away from the center all the way around. If you thought about that given distance being called a radius, you are right. That segment that connects the point on the circle with the center, okay, the plural of radius is radii. And the chord of a circle is a segment, but it has both endpoints that are on the circle. So let's look at an example of that. Okay, so here's our circle. Circle O, we always name circles by their center. So OA is a segment that is a radius. This BC is a chord. As you notice, it doesn't necessarily have to go through the center, doesn't have to touch the center, just both endpoints are on the circle. The official definition of a diameter is a chord that does pass through the center of the circle. It's the largest chord on a circle. An arc is a curve that has a subset of a circle. So it's just a little piece of the circle, and we make the symbol an arc shape over the beginning and the end of that arc. Okay, so here we have a circle with lots of different parts. We've already discussed BC is a chord, but DA is also a chord. It's the largest chord. It's also a diameter. Now OA, OE, and OD are all radii. And here AE is an arc. There are many arcs on this circle, and whenever we have just two letters, we know that it is half a circle or smaller. The interior of a circle is the set of all the points on the plane whose distance from the center of the circle is less than the length of the radius. So let's look at an example of that. Here we have circle O again. This would be the interior of the circle. O is a point that is inside on the interior of the circle. The circle itself is not part of the interior, so just as we were talking about angles before, the same thing applies to circles. And then of course you have the exterior of the circle, which is all the points on the plane that is on the outside of the radius. So it's further away from the center than the radius. So everything outside the circle is in the exterior. Shocking. Okay, the Jordan curve theorem is much like the line separation theorem and the plane separation theorem. Okay, it says any simple closed curve divides a plane into three disjointed sets. We have the curve, its interior, and its exterior. So in our previous example with the circle, we had the circle, its interior, and its exterior on that plane. A region is just a union of simple closed curve and its interior. So this is when we include the circle and its interior together as a boundary. The curve is a boundary of the region. Okay, so for your WSQ summary, I want you to identify the 5 figures as a curve, a simple closed curve, or not a curve. Okay, it's going to be just one answer for these 5 examples, and I will see you in class.